Hello everyone. In this video we are going to start with one of the important article in this lesson, Kirchhoff's law of radiation. Before dealing with Kirchhoff's law of radiation, we need to go through few basic definition. First is emissive power. Emissive power. So according to the definition, if suppose any surface or any object is emitting heat equal to Q through its area A, area of that substance or object, we will consider it is surface area, and T for the time. Okay. Then according to definition, emissive power is defined as amount of heat emitted per unit area per unit time. Amount of heat emitted per unit area per unit time is called as what? Emissive power of any substance. If I want to write the same for black body, then I can write emissive power of black body is defined as amount of heat emitted per unit area per unit time by black body. Because of this, its SI unit is joule per meter square second. But we know that joule per second is also equal to watt. So it is again watt per meter square. Then next term is coefficient of emission. Now what is coefficient of emission? Then it is the ratio. It is what? Ratio of emissive power of ordinary body to the emissive power of black body. So if capital E is the emissive power of ordinary body, EB is the emissive power of black body, this ratio is called as coefficient of emission, denoted by letter E. Okay. In a similar manner, one can define absorptive power and coefficient of absorption. So absorptive power is A equal to amount of heat absorbed per unit area per unit time. So instead of calling absorptive power, I will write AP. There should not be confusion between symbols. Okay. And coefficient of absorption, A is equals to amount of heat absorbed by ordinary body to the amount of heat absorbed by black body. These two definition we will require. Now what is Kirchhoff's opinion about this? Then from Kirchhoff's law, that for black body, coefficient of emission is equals to coefficient of absorption. Means what he wants to say is that A is equals to E. Okay. To prove this theorem, we have one theoretical experiment here. So let's simplify that experiment. For that, consider there is one constant temperature enclosure. This is constant temperature enclosure in which two objects are fixed. First object is a black body and second object is any ordinary body, but both are having same surface area. So let A be the surface area of object 1 and 2. 1 is black body and 2 is what? Ordinary body. Let Q be the heat incident on both the object. Say small a is coefficient of absorption for ordinary body. So how much heat will be absorbed by that ordinary body depends upon this value of A. Say E be the emissive power of that ordinary body. E is emissive power of ordinary body and finally say EB be the emissive power of black body. Okay, these things I have written already. So now we just need to go through basic terms. So already we are well familiar with that. See, what I am telling is, if Q is amount of heat first we will consider about ordinary body. So Q amount of heat is incident on the ordinary body. So out of that, how much heat is absorbed, it depends upon its coefficient of absorption. So if I say QA is the heat absorbed by ordinary body, QA is heat absorbed by what? Ordinary body. Therefore, first I will write for ordinary body, heat absorbed is equals to what? How will you write? Heat absorbed is equals to, say it is indicated by QA, then it will be according to formula A into Q. If you remember, A equal to what? QA upon Q. Okay. So give this equation number 1. Okay. Heat emitted is always equals to what? E. So this is equation number 2. Do you remember the principle of heat exchange that you learn in the 10th standard? So what is the principle of heat exchange? By principle of heat exchange, what we will write? Heat absorbed by ordinary body is always equals to what? Heat emitted. Just put the values, what we will get? Therefore, A into Q is equals to E. Okay, so this is equation number capital A. Now, for black body. For black body, what you can say important factor for what? Now we are studying for black body. Okay, so for black body, what we can say here? See, if Q is the heat incident on the black body, then if Q is the heat incident, its function is to absorb the maximum heat. No, so if Q is the incident heat, it will try to absorb maximum heat. So I will say heat absorbed equal to Q, because heat incident is Q, heat absorbed is also Q. Heat emitted, what is the capacity of black body? It is what? EB. Again, by principle of heat exchange, what we can say? Heat absorbed is equals to heat emitted then what we can say here is that heat incident is Q, heat absorbed is EB, therefore Q equal to what? EB. But from this equation, what you will get? Q equal to, but from equation A, we will get Q equal to EB upon small a. So I will write here E upon small a. So E upon A is equals to EB. Therefore A equal to E upon EB. But what is this value? E upon EB is nothing but what? Coefficient of emission. So A equal to what? E. This will be the Kirchhoff's law of radiation for us, that according to him coefficient of absorption is equals to what? Coefficient of emission. Initially we can use this law for black body only, and then we can apply it for remaining objects also. And the simple theoretical statements that we have gone through, I hope you understood this article. Thanks for watching mahasarkar.co.in. Have a nice day. Thank you.